Hello, I'm Stephen Chin, the VP of Developer Relations at JFrog, and I'm pleased to be able to talk to you about the Singularity and are your deployments ready for this big event which is coming up. So first of all, let's talk a little bit about what the Singularity is and what you should expect. I think this is something which has been talked a lot in the science fiction and the science communities. It's something which we see coming based upon the accelerating pace of advances in general for humanity, but also recently with all of the advances in computer technology, in artificial intelligence, in the exponential growth of computing power. And this is something which is predicted where eventually the computers and artificial intelligence will be more intelligence than the combined brain power of all the humans put together. So what does this mean for us? So first of all, I think the question is, what are the conditions? How do we know when this actually is going to happen? So there's three different conditions which need to be met for us to hit the Singularity. The first is having enough data to be able to model all of the different humans in the world. So there's 7.2 billion humans, 6.2 billion nucleotides. So this is 1 times 10 to the 19th bytes. So we've hit this. We already have 6.8 exabytes of data cumulatively in the world, so we can actually store all the genetic information on humans. The next question is for the entire Earth. Could you store all the information on all the species for the entire planet? And we're not quite there yet, but the growth of data we're certainly going to get here. The next step is, do you have the computational power to be able to actually execute the algorithms needed for artificial intelligence? And this is something which we're quickly advancing on with an exponential rate. For example, the tensor processing units by Google are now on version 4, supports 100 petaflops of computing power, and IBM is also releasing increasingly complex quantum computing, which can solve different scientific and biological problems. And they're already up to an anticipated 127-bit qubit quantum computer, up from only 50 qubits a few years ago. And the final question is, can we build it? Can we automate it? And I think you've all heard about or used 3D printers. I have a lot of hobby projects myself involving 3D printers. And we now have 3D printers which can fully print themselves. So this is an example of a self-replicating 3D printer where it can print 90% of the parts to reconstruct a new 3D printer on its own flatbed. And only a few exceptions to this, like the hot end and some of the electronics, need to be made using other manufacturing processes. So pretty soon we're going to have computers which can self-replicate. And we've all seen this coming in the movies.
In the 21st century,
here's what it all looks like.
Invented like no other. This weapon will be powerful, versatile, and indestructible. It can't be reasoned with. It can't be bargained with. It will feel no pity, no remorse, no pain, no fear. It will have only one purpose: to return to the present and prevent the future. This weapon will be called the Terminator.
Okay, so clearly Arnold had it right. They predicted all the Singularity and all of this coming in the future. And the question is, how far to the future do we have to look for this? So basically the equation here is human intelligence is rising, machine intelligence is rising, and at some point machine intelligence will outpace human intelligence and we hit the Singularity. So I think this is coming soon. This is okay. Actually, there's a slight error with this graph. So I'm not so sure that human intelligence is still rising, especially given the events of the past year. So we'll knock it down a notch. And I think this puts us on a trajectory of, somewhere in the next 20 years, we hit the Singularity, machines take over the world. And what does this all look like? So to figure out what this looks like, I have, with a little bit of help from the experts at JFrog, we've built a prototype time machine, just like what you see in the Terminator. Set the current date, set the target date, and we're going to see if we can go into the future to the year 2040 and and see what it's going to look like once the machine overlords have taken over. So first off, let's check out the boob tube. This is, of course, people are still using these relics, and but the computers don't need them. And apparently, the United Nations has recognized the first autonomous serverless life form. So this is amazing that we've actually recognized that the machines have made it. But let's kind of check out what a newspaper would look like. So clearly the world is not very peaceful in 2020, but we finally we've moved past, and we've progressed deployments where it's not just over-the-air updates on devices like these anymore. This is true over-the-air updates. We're actually updating planes over the air, and increasing security while planes are flying around to block terrorist attacks. So this is amazing stuff. So we're continuously deploying to the edge, and here's a billboard. So apparently it's not cloud computing anymore; it's crop computing. So we've definitely entered a different era of computing, and this actually isn't that far off from reality, because we're already at more than 30 billion IoT devices online, predicted by the year 2025. So we are already well on our way to this future where the devices and the machines outnumber and outsmart the humans. So going back to our roots as DevOps professionals, the question is, where does this leave us, and what can we do? So I think when you look at the human-computer interaction, the relationship between the humans and the computers is the computers are very efficient, they're very fast, they execute automated quality checks, they have machinery and processes to make sure that things are running smoothly, and the humans are the bottleneck in this process. So we have to manually, serially evaluate, execute, think, and iterate to solve problems, and we frankly are slowing down the pace of evolution of the machines. And this is true not just of software development, but it's also true of software pipelines and continuous delivery. So how do we speed up our continuous delivery so we're not getting in the way of the machines, because they're not going to stay that happy for long if we're blocking up the pipeline with our very small pipes and our manual buckets which we're carrying around. So the first step towards this nirvana of automation is making sure that we actually are implementing continuous delivery processes which enable us to be efficient, to have different quality gates, and make sure that we're as automated as possible where exceptions don't occur. So you'd have your different inputs coming in from source control systems going into your favorite continuous integration server. It could be Jenkins, it could be Tecton, it could be Spinnaker, any of your favorite CD Foundation projects. As it goes through that, you want to have different systems which you're deploying to. So you typically send out to a container registry or a package management system like Artifactory, then release to Kubernetes clusters that are running in integration servers, system test servers, staging, production, and in each of these you have different quality gates which it has to pass in order to go to the next step. So these are either automated tests or different quality measures for security, for making sure that it meets the production requirements, for performance requirements. And if this is fully automated, then you can get to the nirvana where you can continuously deploy every hour or possibly on every check-in, making sure that you're only pushing releases to production that meet all the quality requirements and getting rid of all the human intervention along the way. So once you've automated all of this and you've increased the speed, the velocity, your ability to deploy into production, the next question is how do we make sure this is working and is secure? And so when you're looking at how you secure your DevOps pipeline, you again have your phases, your code going from development into testing, into staging, and finally into production. And the trick here is that the farther you go down the DevOps pipeline, the more costly it becomes to solve problems. If you catch things in development, it's fairly easy. testing, again, you can fix it quickly, you can solve security issues, but once you get into staging, into production, or it becomes a customer issue, the cost to fix it, the amount of time it takes to fix it, exponentially goes up. And so what you want to do is you want to shift all of your security requirements left. You want to put more tools in the hands of developers, which enable them to be able to do those quality checks, to check open source libraries, to make sure that they're secure, to make sure that any issues are caught really early in the development process. And we're basically shifting and pushing security to the left, which is allowing us to work faster and to please our new autonomous overlords, the robots who are taking over. So I think we've solved a couple of the big problems. Now the next question is, when we get into production, how do we make sure that we're observing, we're monitoring, and we're tracing in a way which allows us to iterate continuously? And one of the ways of accomplishing this is the End-to-End Visibility platform, which we're building out together with JFrog and all of our partners. And we announced this recently at SwampUp. And it includes, on the left side, with developers and operations folks, having all the collaboration tools you use together, like Slack, Jira, and Microsoft Teams. In the center for your observability platform, allowing you to work with all of the different observability tools like Datadog, Splunk, Dynatrace, Elastic, and others, which give you this full visibility with metrics, logging, tracing coming out. And then finally integrating with IT service management tools like PagerDuty. And when you bring this all together, this gives you this code to production visibility and traceability, all on top of the JFrog platform. So putting this back together, you need to be able to trace all of your dependencies and have quality gates. You need to have security, which you can shift and enable developers to be more powerful. And you need all of this put together with an end-to-end observability platform. And this is a lot of what we provide with the JFrog platform, with Xray, our security product, Artifactory for package management, and all the partner integrations we're doing with all of the other folks in the DevOps ecosystem for collaboration, ITSM, and observability. So now that we've built out this end-to-end system that's fully automated, we can build code, we can deploy to edges, we can deploy to the cornfields, which are the new cloud. Now, where are we with our new autonomous overlords? So I think that basically where things are being driven to is the reversing of the man-machine ratio. Historically, you had people driving systems and pushing machines. Now it's the opposite. You have machines which are doing all the work, and then you have operators which are only intervening in areas where there's exceptions or there's processes to intervene. And we're pushing this even further with technologies like AI ops, which even limit the amount of data which you need to look through as an operator and flag on key trends or insights, which allow you to focus on just the issues which are most critical for your production timeline. And this takes us to a symbiosis with our robot overlords. We're now, rather than us being working for them or them working for us, we're now working together and collaborating on things like teaching kids how to program and improving our society. So one of my hobbies is doing education for kids in STEM. This is the Now robot in a workshop which we did for some of the local schools, which was awesome. And I think that now that we've automated our DevOps pipelines, it's time to teach the next generation how to use technology, how to collaborate with the robots, and to create a harmonious environment where we can work together with our robot overlords and build a better future. So, thank you very much for watching my talk, and hopefully you've learned a little bit on how to automate your DevOps pipeline, how to identify what's coming in the future, and how to have a harmonious future together with the robots when we all get past the Singularity. So, thank you very much.